Okay everyone, welcome to Physics 221 Lab 5, our lecture for this week. And there we're going to look at the critical angle. Remember this is due at the end of each week, and please remember to observe the correct lab format. So this week's lab is based on our knowledge of Snell's law, which is N1 sine theta 1 equals N2 sine theta 2. And then subsequently the critical angle is sine theta c equals nr over ni. So, remember the critical angle is where you experience the phenomena known as total internal reflection. So what this is the point when, depending on the material, the light is reflected back into the medium rather than transmitted out. So, as the diagram shows here, some of the light, where the incident angle is 0 degrees, the light will be transmitted with little to no reflection, or it's straight back down, or as you go through and the angle of incidence changes here, this angle, more and more the light will be reflected, and less and less and less will be transmitted, until you get down here to the point, and this angle is called the critical angle, to where all the light is reflected internally. So what I'm going to have you do this week is I'm going to have 3 different situations. Air into water, and remember for air, assume n equals 1. Okay. I want you to go air into water, air into glass, and then water into glass. And notice that the critical angle is the reflected indices are reflected over the incident one. So in all these transitions you're going to make calculations accordingly. So what you are really going to need to do here, this is another Excel lab in question, is you're going to have to work with the incident and the reflected one. So your incident one is the one going to be started with. So for the first case, that's going to be air. And what you're going to do is you're going to change the incident angle, and then you're going to calculate the reflection angle. Okay. At some point, you will get something at this specific value, meaning where the transmission will be 0, and more importantly, your graph will basically make some interesting value. So let's go take a look over at the first one here. So here is just a generic situation I have set up where I have incident angle and refraction angle. Now we're going to have a couple indices of here in incident, in refracted. So for the first one, it's air, and I'm just going to make up one here, 1.59. I don't know if that relates to anything in physically, but I don't want to use the values we're using. Okay, so how you're going to do this is we have to remember what Snell's law is. So we see N1 sine theta 1 equals N2 sine theta 2. Well, let's just make our Ni 1, so that means we have to get a relationship for N2. So now we see N1 over N2 equals sine theta times sine theta 1 equals theta 2, or finally we see theta 2 is arc sine N1 over N2 sine theta 1. So, a couple little tricks you're going to need to work through this. First, we have a sine of, and you have the N1 over N2. So this is, again, going to be a sine of, it's our E2 divided by the D2. Put our dollar signs in here so we don't iterate these. Times sine. Here's the trick. You have to do degrees of this angle. Okay. Close that out, and then we're going to fill this down in a second and see what happens to our angles. Okay, so now, like I said, we're going to fill this down. Do it down to the 90. Copy cells. And what you're going to notice is, oops, I don't know what it's doing here. Oh, sorry, this should say radians, not degrees. And this should say in terms of degrees. So, a couple little things to fix. Apologize for the error. And now that we got that sorted out, what you're going to notice is at a point, it's going to fill it up, but then at a point, you're going to get this number. And what this means is your critical angle happens somewhere between 38 and 39. Or in particular, using the equation degrees a sine of the d2 over e2, which is where our relationship is between the values, you see it's 38.97. So this should give you a pretty good idea how to work through these problems. Again, remember to observe the lab format, and if you have any questions at any time, please email your instructor.